Question 3. Question 3.1. Which is the correct expression for Kw? That's just something to learn. Kw is the H plus concentration multiplied by OH minus concentration. The answer is C. Calculate the pH of pure water at 10 degrees C. Give your answer to 2 decimal places. Well, Kw is H plus multiplied by OH minus concentration. If I have a water molecule dissociating, breaking up, then for every H plus particle I make, I'm going to make one OH minus particle because they've come from the water molecule being dissociated. So H2 makes H plus plus OH minus. So every time one of those is made, one of these is made. So H plus concentration has got to equal OH minus concentration. So instead of H plus multiplied by OH minus concentration, I can replace the OH minus concentration with H plus. So Kw is H plus squared. Kw equals 2.93 times 10 to the minus 15, so H plus squared is 2.93 times 10 to the minus 15, so H plus concentration is the square root of that, 5.41 times 10 to the minus 6. I do minus log to the base 10 of that, because minus log to the base 10 of hydrogen ion concentration is pH, minus log to the base 10 of 5.41 times 10 to the minus 6, 7.27. Don't worry that it's not 7 exactly. Temperature, changing the temperature can alter the pH of water. Suggest why this pure water at 10 degrees C is not alkaline. Well, it's only alkaline if I've got more OH minus than I have H plus. So if I've got an excess of OH minus, it's going to be alkaline. If I've got an excess of H plus, it's going to be acidic. So the fact that I've got equal concentration of H plus and OH minus means that it's not alkaline. Just because its pH is not 7 doesn't mean that it's just because it's higher than 7 doesn't mean that it's alkaline. That just means that I might have changed the temperature. I might have added some alkali, but I haven't. I've just changed the temperature. That's how I've altered the pH. So the fact that H plus concentration equals OH minus concentration because it's pure water means that it's not alkaline. Calculate the pH of 0.031 solution of calcium hydroxide. Well, calcium is in group 2. So calcium's in group 2. If calcium's in group 2, it forms Ca2+. It forms a 2+ ion. It loses 2 electrons. And a hydroxide ion is a -1. So calcium hydroxide is CaOH2. It's got to have, because 2 pluses needs 2 minuses to balance out. So every time 1 mole of calcium hydroxide dissolves, it makes 2 moles of OH minus. So I've got to multiply the OH minus concentration is twice the concentration of the calcium hydroxide. So it says calculate the pH of a 0.031 mole solution of calcium hydroxide. So if the calcium hydroxide solution has got a value concentration of 0.131, then the OH minus that's made when it dissolves, when the calcium hydroxide dissolves, I make 2 moles of OH minus, so it needs multiplying by 2, 0.0262. Now then, I've got OH minus, I need H plus if I'm going to work out pH, so Kw plus H plus OH minus, that's why they've got you to do that in the first part of the question. Kw is 2.93 times 10 to the minus 15 from the first part of the question. H plus we don't know, OH minus we've just worked out, so H plus is 2.93 times 10 to the minus 15 divided by 0.262. I've worked out H plus concentration, minus log to the base 10 of it, and it comes out as 12.9514, and I'm going to put it to, I should really put it to 3 significant figures, because I've got 3 significant figures here, so it should be 12.9 or 13.0. The 0.0131 solution of calcium hydroxide is a saturated solution. If I'd used magnesium hydroxide instead at the same concentration, with the pH would be larger or smaller. Well, magnesium hydroxide is less soluble. As you go up group 2, the magnesium hydroxide, the hydroxides become less soluble. So magnesium hydroxide is less soluble than calcium hydroxide, so less of it's going to dissolve, and therefore the pH is going to be smaller because magnesium hydroxide is less soluble than the calcium hydroxide. So it's a question about solubility.